Okay, my friends, I'm going to do this kind of quick. I am going to have an ultimate showdown with Fermilab. They're talking about their muon experiments and that they found something surprising, which is unsettling, basically, leading to an ultimate showdown between my work and their work. I showed them these same particles they wanted to find. These are the muon, and that's the electron neutrino. All right, the fixed particle and the point particle. And I'll explain to you just exactly what they are, and then we actually found them in our light experiments. So those were the two particles, the fixed and the point from Fermilab. And here they are in our light experiments. Okay, so this goes back quite a ways, 2013. This is Don Lincoln, and I engaged with him, very, very deeply about this, and he dismissed it. Now, these are the particles. We're going to get into exactly what it says about these particles, but the bottom line is the extended particle, which is the black one, has a fixed size. That's it, just one size, although they may have a fuzzy edge. I'll show you this. The point-like particles are mathematical abstractions with zero size. Now, I don't necessarily agree with that, but they're very, very tiny, and they don't have any mass that I can tell, but they burn like hell. It says even those zero-size particles have extended fields, which, yes, the effects are huge due to the effect of the field surrounding them. That's Don Lincoln. He had some questions. I said, what about my research? And it didn't work out. Now they're talking about new physics, and absolutely, it's electron flood theory is the new physics. Now I wrote this long ago, and I did this stuff for my whole life. That goes back. You can't weather something like that. And it's all about dipole flood theory, that there was no such thing as a solid core nucleus of a positive. It was just impossible. And have a couple of little electrons floating out, have the same charge but opposite and not sucked into it. It just, nothing worked. Plus, they never take into account the isotopes. It's always the big solid particles, but I'm going to tell you right now, between every one of these particles, in other words, hydrogen is not one proton and one electron. Hydrogen is about 1,825 or so electrons. Well, dipole electrons. That's what makes up the core. When you smash them up, they get bits and pieces all over the place. This is what they get. All kinds of the same debris that we can see, but we started with this. We don't have to do all this before we get down to that. And then from that, we can get down to these particles. All right, let's recap. We're going to have the ultimate showdown between their work and our work. It's the same particles, and they have the same characteristics of the masses and so forth. But however, they're using gigantic particles like this, bam, and then they get all kinds of debris. They don't realize these are made out of electron dipoles. All right, electron dipole flood theory. So when they smash them apart, they do get down to the tiniest little bits and pieces here and there. But they also get down to the photons, which are the photons I will show you right in our work is here. This is what we started with. That's what light is. Now, there are some neutrinos that are not quite at the photon phase yet. That's why they call them different flavors. They have different masses, basically. All right, so don't forget, that's how they're able to see these little particles, but they just see them in literally debris. They don't know where they came from. They're just a mass of debris. We can actually see them propagate. Let me show you start to finish. We accelerated light. We can separate the black from the white. As far as I'm concerned, that's fission and fusion. Okay, I know it sounds braggadocio, but it's true. If it's true, it ain't bragging. This goes back to about 2015. I contacted Don Lincoln at Fermilab. Said, we found your particles, which are here. And I also showed him and copied him in with the Russians that had done this in outer space and created literally a black hole. They didn't know what they did either, and that didn't go well either. So, but during the experiment, the guys on Earth, they couldn't believe it because it opened up a black hole in the middle of these charged particles in a vacuum chamber in almost zero gravity. So This literally proves my electron flood theory, dipoles. The black parts can disassociate out in space. I didn't realize that. But then from our research, I knew they could disassociate because we disassociated them. Right here. All right, the black came away from the white. All right, remember up here? Here they are, the black and the white. And they're coming down here like a rocket ship. Because they're accelerated. You see this? This is acceleration. And they're talking about this right now. Continuous beam, laser acceleration, creating all kinds of things that they don't understand yet because they haven't done this. This is a Venturi. It creates crushing of all these fields. And those fields do not want to be together. That's why it does this. And these are repulsion patterns. They're not interference. This is single slit. There's no this and that. This is one shot. And it's accelerating because it has to, because that's a Venturi. And the particle now is beginning to manifest itself until it gets glowier and glowier as it advances through its neutrino phases. All right, more and more energy, and then all of a sudden it pops into a photon. And that's the photon right there. Now, the leading part of the photon, as it comes through, gets charged up. It'll get like this, and it'll go, whoop, and that'll go to the front. They call it the muon wobble. That's the spin that they're talking about. They can't account for any of this stuff. But now they're saying, oh, there must be some kind of field on the black particle. It's just the opposite. The field is on the white particle. All right, just to recap that. We went from the particles that CERN and Fermilab and all of them see, but they're just in the debris of particles. We made them show up by accelerating laser light. The different shades, we have the blue, the green, the red. The red is the slowest, and they spin. The particles spin. They don't flap like waves. It's nothing like this. They spin like that. And as they spin, they create a pattern, and I'll show you on the back wall. But they're together. That's a dipole. And there's two dipoles back to back. That makes a photon. Each individual are gluons, and that is an electron neutrino, and that's a muon neutrino. And it's precisely what they say at CERN and the rest of them. The muon neutrino, the black one, never changes when it hits. They hit heavy water and break these particles, and so that's where they see them. We're focusing them. We're doing a whole different thing. They're just seeing them shatter. Then they see the electron neutrino show up and make showers. So they see these little beams come down and pew, 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 pew in the water. We're creating a continuous electron beam that radiates 100% electricity. That's all that is electricity. That is electricity. Electricity. When you pump up your batteries, that's exactly what you're putting in your batteries. Why cannot we use that and harvest it right at that point? Like this. Whoops, can you see that? The laser comes down. It shoots it into the Venturi. The black ones can't get through. I showed you that. They can't get through. The white ones just come through photodiode down into harvest them. But you need to be able to pick up all the frequencies of the light, because red will be one frequency, and it's very slow, and it doesn't have a lot of... Here's what they look like when they come. Red will be like this, way out like this. Green will be like here, and blue will be like this. And I can show you these, and I will. And the end result is that the Venturi, you have fission, and now you have divided off the black stuff. We don't want that stuff. And you take this and shoot it down into a battery stack, and you're golden. And this could be almost dirt cheap. And you can see there's an enormous amount of increase in luminosity. That means there's an increase in energy. That's exactly the signature of energy, is luminosity. All right, this is Don's article. I agree with it 100%. In summary, the extended particles, the black one, have a fixed size, never change. They may have a fuzzy edge, which I showed you. The point-like particles are zero size, is what he's saying. I don't know if that's possible, but he says even zero-size particles have extended field because of their magnetic field effects surrounding them. The fields are magnetic fields, and they really get puffy and they get small. The point particles, the fixed particles don't glow, they don't do anything. They're just like a bowling ball. And I show that very, very clearly. All right, that's what these guys are doing, smashing huge things together and getting piles of debris, and that piles of debris look exactly like that. And they try to figure out what they're seeing by how quickly they decay and how they spin and all that stuff. The closest to the nucleus is going to be the blue. They go out like a rocket ship. The red is just sort of laying around, so it just doesn't go too far. The brighter colors, the blue, the green, and so forth, they really take off because they're right down next to the nucleus. Because these are being smashed together, huge things like this, and the little bits these are little bitty pieces. They're taken off by themselves. All right, that's why they can't even explain isotopes. If they just stop and think, what would happen with an isotope? Little bits and pieces are going to go flying off. All right, and I'm not going to bore you with all the details, but we accelerated light. We saw it get more and more, like here it is right here as it's accelerating. You see it? It's accelerating. The wave is pulling forward through here, and then it explodes like an atomic bomb. Literally, it is a subatomic nuclear bomb. That is exactly what it is. And as that photon accelerates, it goes through its neutrino phases. This is a package of energy. Now it's a real photon. Here it splits and the whites go away from the black ones. All right. And then when they come through the other side and they match back up, they can create Higgs fields. These are real Higgs fields. That's where that white comes through and it starts to just smash into the black ones, and they just spin into new particles. And they think it goes just the opposite. Higgs fields make the other particles. No, the other particles make the Higgs fields. Okay, remember I told you the red is very slow. This is all the same photon. Because, it's going so fast, one click and you get the whole 9 yards. And this is as it's growing in strength. Here, and then it turns into a real photon with the two gluons back to back. And here it starts to concuss, and I don't know what's happening here. But here it splits apart. Now, I can show you this in the green too. Now, you see how the white is ahead on the bottom here? And now it's behind it back here? This has had a flip. This is what they do. They roll down the road there on their axis towards the Earth. And I'll show you the green doing exactly the same thing, the same particle. All right, this is the green, same photon with the two whites and the two blacks. Now, in the same neutrinos as they build energy. Now, here the white is in front. Here the white is still in front, but look how blurry it looks. And this is much less bright than this. This is going to flip to the back, and the white one is going to flip to the front. And then that one will charge up, and then it'll flip, and it'll flip. We can see it much easier with the blue. Hold on a second. First of all, the blue is going to be spinning like this, and we're going to see a spinning tube of particles. And that's what light does, it spins. Now, let me show you the blue, and you can see how this is literally screwing through the Venturi. And that's what it is. It literally is. It's just like this. It's going just like this. So some goes under this way, some goes over that way, some comes through the middle. Most of it's getting through the middle and then pushing like crazy out to the sides. So this is where it's really concussed in the middle. And this is a pattern on the back wall. After it comes out, it creates these, what they would call interference patterns. They're not. They're push. You push me, I push you. You push me, I push you. And they create these lines right down the center, and they call them interference patterns. They are not interference patterns, they're repulsion patterns. All right, remember how I said it's going to spin real fast, the blue? You see how tight that spin is? All you can see is one little white dot. That's why the blue, really don't work much with the blue, because you can't really do much with it. But you can see it here. It's coming through the Venturi hot. It's almost going perfectly straight. And then all of a sudden it drifts to the left. This is all one picture. And that same particle is now slowing down. It's spinning to the right, which means it would drift to the left. And it is. And out here we can see there is actually the two particles, the two whites. You can't really see the black. I don't know. Blue is really, really powerful. And we can't see much with it. But you can see those are the little tubes of light. Those are light particles. All right, I talked about the Higgs fields. These are the particles coming directly at us. And all they are at this point is the white. You see almost nothing here. You see these little spritzes? We're looking at virtually nothing. And it's coming out, and as soon as it can, it reattaches to the black particles and makes them spin. That's what the Higgs fields are. The white is all by itself now, bam! And you see all these little spritzes coming out? They're hitting up and starting to create particles. Now, what about this one? You see that? There's some energy there. And that is a particle. However, I believe that one there is spinning backwards. And instead of sending its energy out, it's sucking it in. And then I can see another picture that we see, I believe, is that particle interacting with one of the normal Higgs fields, and it's the strangest thing you ever want to see. All right, now, you see what you see, but these are the normal Higgs fields. Scads of them get created. This is an anomaly. That little white particle there, hold on, let me turn this on. That little white particle looks like it's coming from underneath this Higgs field, and here it is, and it's starting to show itself, has some kind of a definition to it. I don't know exactly what it is, but it starts to interact with this field. And what happens is it's starting to set up its own field, but it's going the wrong way. It's going the wrong way. So what is the result? The result is the outside edge of this wrong way field, instead of going with the other fields coming down this way or everybody's going the same way, it is trying to go this way, and this field going the correct way rips a cord right off of this field. That's all I can tell you. Whenever you see white, that's excessive interaction. This little cone, I don't know. But I'm telling you what, this one here is spinning this direction. All right, so this one is spinning down. This one's spinning up. That's a reverse particle. I don't know what to think about that. But that's the only time I've ever seen it. And I've seen thousands and thousands of these. Here it is right here, the Holy Grail. Muon neutrino, electron neutrino. Be able to separate them, create electron showers, which can be trillions of electron volts. And we can do it. We've proven we can do it. That's an electron shower. There's absolutely no question. And these black balls are the muons. Of that, there is no question. We started with light. And here they come back together. The muons never change size. They're fixed particles, exactly what Don Lincoln at Fermilab says. Why he wouldn't interact, I do not know. But now it's between me and them. So there it is right there. Findings at Fermilab show discrepancy between theory and experiment. My experiments specifically. Oh, they showed you that the red just doesn't have much power. When it comes to, it's just like this. The green is a little faster, and the blue is like rocket ship. It's, they're spinning, and they spin like crazy. And whatever's in front of it's got to get out of the way. Now, I'm showing you the green is reconcussing out here because it's so fast, it's moving through the particles in the air. This created a lot of disturbance, and it had to plow through the disturbance from the red, but just pushed it out of the way. And back out here, it's concussed where it normally would have concussed. All right, but let me show you something else here. Oh, don't forget, this is nothing more than red pulsed laser going through the air, and it's just beginning to accelerate. That's why it's glowing so heavily in the front. And then all of a sudden, it takes off like a rocket ship here. Before, it was right here, just starting to glow, maybe back here somewhere. And now you see the wave is all distorted and pulled right out of the way. I mean, it's accelerating like, I don't know how fast it's going, but it's going much faster than the speed of light, because that's the speed of light, and that's accelerated. Now, what happens here? The black cannot get through with the white. They are dipoles when they started out. They are these dipoles, wherever I had them here somewhere. Well, you've seen them before. The black and the white attached together. Here they are right here. This is that's what light is. It could be blue, it could be green, it could be red, and I think there's probably all kind of other different colors in there too, because it's nothing more than the glow of the electron part. That's all you see. Whenever you see color, that's all it is how glowy is that? All right, now, it's pushing against particles here, and this will go flip, 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 and that's what it causes the muon wobble. And that's the spin on their axis they talked about at Fermilab. And these are the Fermilab particles. So, it's a mystery to me why, because we might be able to get free energy out of this. And this goes back many years, because I ended up having to go, well, I didn't have to, but I decided, well, I'll go to University of Geneva, take particle physics, which I did. And I showed them all my stuff, and they were pretty impressed. They didn't discount anything I said. And I showed them, I said, they weren't focusing, and they didn't use CMOS. Now, CMOS, you can see individual electrons and photons. Nobody knew this before. Well, we did. Rod and I knew it, but they didn't. And they just said, no, you can't see it. Well, of course you can see it. We knew that then. And they should have known it, but it made things too simple. But now they have to do it. And let me just show you something. See, this is CMOS. Image sensor detects individual light photons. This is back 2021, but we were doing this in 2014 because all these pictures I'm showing you, showing these particles, were taken back in that time frame, 2015, 2016, right around there. Some of them fairly recently, but not too many. Most of them will go back to then, and then, people gave up on this stuff because it was just so hard pushed back at. But here's the particles. Okay, look at this. That's the black particle. This one time, it's engineered just enough to let some black through and push the white ahead of it. And the white goes ahead because it's field affecting all that stuff in front. That's not actual particles. It's field affecting like a flutter. And that's because it's coming through pulsated. And the black right now is just a black little strip just pushing the white ahead of it. And that white will glow and burn a house down from an atomic bomb. And it'll just smoke up like this. And then the next thing will happen, the black will hit and out goes the house. They're two separate particles. Okay, my friends, this is it. The laser pulsing through the Venturi, collecting electrons into batteries. And it's exactly what Lawrence Livermore, I think this is Lawrence Livermore, they all understand this now. The electron showers are extremely high energy. When you get that really white shower way up here, large shower cones created, high energy showers. Down here, lower energy showers. But they come through the Venturi. These slam into the Venturi and back out. Now they're showing some of them going through. We can make none go through, zero, none. Or we can let a little bit through. I showed you the two different scenarios there, and I will again right now. This time here, some of the black came through, pushing the white, which is a whole different set of circumstances to where you have 100% white. You see it? 100% white. There's not a taste of black coming through there whatsoever. And it's just bang, 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 slapping the white. The white is being ejected out of there like unbelievable. And the white is just all is electrons. And again, you charge your battery up with electrons, and it doesn't take on a whole lot of extra weight. It does increase the weight, but not much. Not much. The black, yes. The black is what matter's made of. The black is the mass. Okay, I've been pretty clear about my evidence, and it's as far as I'm concerned, it's overwhelming. And again, these are the particles, and this was the article that tripped me off today. This came out today, and it says the ultimate showdown. Exactly. This is August 13th, and this is Fermi National Laboratory. Now, I am part of the national part of the American society here. I should be able to at least be able to speak. Now, and right now I was told they're not going to pay 1 minute of attention to what I'm showing, which could be monumental without looking at it. And I did all the things that anybody would do to prove. Like I said, I went to the University of Geneva. I have so much work in this realm. Nobody can compete with all the stuff I did. but it's long ago, but I knew it then, and I didn't care. And I went into electronics. I started my own business. So none of this stuff is new to me. The thing that's new to me is when Rod did the light experiments and I could prove it. When I could prove it, I said, well, let's talk. And nope, they wouldn't talk. So that is, to me, that doesn't look favorable on the institutions that we rely on to do the research that we're hoping to help our lives. I don't know, maybe you see it a different way, but what have I not shown? Let's see what they have to say in their video. Okay, this is the ultimate showdown. This is Fermilab. I showed my information. They showed theirs. Ours is better, as far as I'm concerned. Now, they're asking about, questions and suggestions and, general information. I think maybe somebody could contact them and ask them if they would look at my research. I mean, if we could get free energy, we're in so much trouble right now. It's just unbelievable. And to have what I showed just be fluffed off, and it's so inexpensive to do that, I think that has a lot to do with it. But I'm not going to make judgments. See what you can do. See if you can get anybody interested. They all should be. And I'm sure the people that want free energy are interested. I showed you how we can harvest that white, and that white is electricity. All right? That's all I have to say. Thank you. I love you all. Bye.